on heating with the calcium hydroxide gives E. So first of all you will heat basically compound B with the calcium hydroxide. When you are heating, that is B, which is also being given that B is a carboxylic acid. So over here the important point I want to make is that we know that B is a carboxylic acid, and B actually when it will be heated with the calcium hydroxide, first of all basically it forms the calcium salt of the carboxylic acids, and then it forms the product because the heating process goes on. So therefore you can say that in the B structure you must have CH3 group because eventually this B structure is giving you a E structure when you are heating it with the calcium hydroxide, which is nothing, it is the pyrolysis reaction. So therefore in the carboxylic acid B you must be having CH3 group. So if you generalize this part also, that E is being formed by heating B with the calcium hydroxide, and thus we have the strong reasons to claim that B will be acetic acid. Now when you heat acetic acid with the calcium hydroxide, what first of all you get is the calcium salt of carboxylic acid, and the second thing which you do is that you heat that substance, and by heating what it causes basically the cleavage of all the, or not all the bond, but yes, cleavage of the bonds. So therefore the structure B has to be an acetic acid and structure E has to be a ketone. There is no other option left. Another point is that B is also being formed by the oxidation with the KMNO4, that is of D. Okay. Now first of all, it is being said that the oxidation of D with the KMNO4 gives B. So therefore B cannot be a first of all carboxylic acid. So therefore we can say that D is first of all a carboxylic acid, and that is being formed by the oxidation of D, and we already know the structure of B, that is acetic acid. So therefore the important point, or what the information which you can extract it directly, is that if B is the acetic acid and that is being formed by the oxidation of D with the KMNO4, that means KMNO4 is the reagent which clearly indicates that D is basically an alcohol. D is basically an alcohol. So therefore the D has to be a ethanol, because it is the only 2-carbon carboxylic acid which is being formed, from the or you can say the carboxylic acid B is being formed which contains 2 carbon atoms. So therefore this B carboxylic acid can be formed only with the 2 carbon atom alcohol, that will be a D actually, and the 2 carbon atom alcohol can be the only one, that is ethanol. So therefore till now we have come out with the 3 points. The first point we said is that E does not give tolerance test, does not give Fehling solution test, but forms 2,4-dinitrophenylhydrazone. Second point which we made out is that E is formed by heating B with calcium hydroxide, so B has to be a acetic acid. Now because D on oxidation is forming B, so if you can say if you reverse this reaction, that is the reduction of the carboxylic acid, in that case you will straight away say that D has to be alcohol, and because D alcohol is giving you a B which is a 2-carbon carboxylic acid, so therefore D should also be a 2-carbon alcohol, that can be only ethanol. Now another point which we can make out over here is that B and D both are formed by C on hydrolysis in acidic medium, and thus C should be an ester. Well, we know that B is a carboxylic acid and D is the alcohol, and we are also being given that hydrolysis of C under acidic conditions give B and D. So we are basically carrying out the hydrolysis of C, and the hydrolysis of C is giving you a one molecule of carboxylic acid and another molecule of alcohol. So therefore now you will straight away say that C has to be an ester. Now you can easily form the structure of C because you know the product of the hydrolysis of esters. You know that B is acetic acid and D is basically a ethanol. So using these two you can form C, which actually will be ethyl acetate, that is CH3 COO C2H5. So the reaction of C, that is CH3 COO C2H5, in the presence of acid, it will fetch you CH3COOH, which is B, and C2H5OH, which is